Sometimes the plate boundary cannot be associated with oceanic crust. So just in continental crust, we can have rifting. It's the very beginnings of that divergent plate boundary. So in the image here, the block diagram, you have that thick continental crust and it begins to thin. The thinning occurs through faulting. You get a bunch of little block faults that thin out the crust. And so earthquake activity, eventually that crust will get thin enough that magma can rise up and go through the fault system, through the cracks, and erupt volcanoes along that rift valley. This would be like the East African Rift Valley, or the Horn of Africa, and then to the south, there's very deep lakes, Kilimanjaro, big volcano, and you have the rifting of Africa there. Okay. So if over time, if water floods that valley, it becomes a mid-ocean ridge and basalts would be coming out of that and you would get the generation of oceanic crust. Now here's that East African Rift Valley, the very deep lakes, Kilimanjaro, and it forms a line there. So eventually enough time passes and the sea could flood that area and we would have a new plate boundary. Right now in some of the deepest lakes there are basalts forming. I'm going to move my face out of the way here and go to the north. See here, 1, 2, 3, it's a triple junction with the Red Sea and the Gulf of Aden as well. And in the Red Sea there are definitely basalts. There's a mid-ocean ridge there pumping out new oceanic crust. And the same thing with the Gulf of Aden here at the triple junction. Another point where we're not having oceanic crust is, let me turn my face off, would be where continents collide. So I mentioned this before. You have, I tried to use my hand. I'm going to turn my face back on. There it is. I'm just going to put it up here. Plate collision, where you have two buoyant, floating high because of isostasy, pieces of less dense granitic continental crust, and they hit each other. Maybe there was an ocean basin, it subducted away. Now we have two pieces of continent ramming into each other. When that happens, neither of them is going to subduct. Neither subducts. The plates continue to move, so the crust is going to buckle and there's going to be faulting that occurs. So over here, the plate, this purple is, well, the gray here is oceanic crust. It has subducted down, the ocean basin closes, and now we have a suture where the last remnants of the ocean was. That marks the boundary between one plate and another. And then we get these pop-up structures. You can see a little V-shape here, maybe popping up some mountains. And this would be like we have in the Himalayan mountains, where we have really, really high mountains, and also how the Appalachian Mountains formed. So here is a look into that. Let me keep moving this out of the way. You turn your head. So the plates are coming together. You have really long faults, thrust faults that come through here, and it makes these pop-ups and really high mountains, where you have continent-continent collision. So this is a special kind of convergent plate boundary.